Welcome, my dear students in Prep 3. Let's continue our lesson about the mean trigonometrical ratios of an acute angle. We studied in part 1 that if you have a right angle triangle and you want to get the trigonometrical ratios of one of the acute angles, for example, angle theta, sine theta will be opposite over hypotenuse, cosine theta will be adjacent over hypotenuse, and finally tan theta equals opposite over adjacent. Also, we said if you have two complementary angles, the sine of the first angle equals to the cosine of the second angle, and vice versa. Sine the second equals cosine the first. Today we will solve some important exercises. This lesson is very useful to you. Let's start with the first exercise. Choose the correct answer. Number 1, if sine 30 equals cosine theta. So here I have two angles. The sine of the first equals the cosine of the second. It means the two angles are complement. So angle theta complement angle 30. So theta will be 90 minus 30. So I'll calculate 90 minus 30, which is 60 degrees. This is number 1. Number 2, if x and y are the measure of two complementary angles. If cosine x equals 4 over 5. If we have two complementary angles, cosine x will be sine y, the same as sine y. So sine y will be the same number, 4 over 5. In triangle ABC, if measure of angle A equals 60, sine B equals cosine B. Here we have the same angle and the sine and cosine are equal. It means angle B will be have 90. Okay, because I want two equal angles and at the same time complement. So angle B will be 45. So we have angle A 60, angle B 45. I want angle C. I'll use that the summation of angles in triangle 180. So 180 minus 60 plus 45. The result will be 75. Number 4, if a triangle ABC is a right angle triangle at B, then sine A plus 2 cosine C. Right angle triangle at B, it means A and C are complement. Okay, so I can write instead of sine A, cosine C, and instead of cosine C, sine A. Okay, let's try the first. I'll write instead of sine A, cosine C. Okay, cosine C plus 2 cosine C equals 3 cosine C. Here we don't have 3 cosine C, so I'll change and try to write instead of cosine C, sine A. Sine A plus 2 sine A equals 3 sine A. Okay, so this is the right answer. 3 sine A. Number 5, if measure of angle A 75 and sine B equals cosine A. Okay, 75 sine A equals cosine B. It means A and B are two complementary angles. It means the summation is 90. B is an acute angle, then measure of angle B by the same way. 90 minus 75 equals 15. Number 6, in triangle ABC, if measure of angle B 90, then cosine A plus sine C equals what? Measure of angle B 90. This is a triangle ABC. Measure of angle B 90. It means the two angles A and C are complement. So cosine A equals sine C and vice versa. Okay, let's write instead of sine C, cosine A, and add cosine A plus cosine A. It means 2 cosine A. So this is the right answer. Okay, let's continue. Let's take another exercise. Here, for example, ABC is a triangle in which AB equals AC equals 10. So here we have an isosceles triangle. The two sides are equal. BC is the base equals 12, and AD, the ray AD, is drawn perpendicular to the side BC. to cut it at D. We should draw. Let's start and learn how to draw step by step. The first step, ABC is a triangle in which AB equals AC equals 10 and BC equals 12. So I draw a triangle ABC. This triangle is an isosceles triangle. The two sides here are equal and BC equals 12. Okay, let's continue. The ray AD, so I'll draw ray from A. This is point A. So I'll draw ray from A. Perpendicular to BC, okay, like this. Perpendicular to BC. To cut it at D, cut it at point D, okay. Find the value of sine B plus cosine C. Okay, I need sine B and cosine C, so I need to get the three side length of the two triangles here. The first triangle and the second triangle. We have this side 10. Can we calculate the length of this side? Yes, we said before, if you have an isosceles triangle and AD is perpendicular, so AD bisects the base. So this part will be 6 and this part will be 6. 12 divided by 2. So now we have the three sides of the triangle. Okay, so here we have 6 centimeters and here 6 centimeters. Now I can calculate sine B. Very easy to calculate sine B. This is B. Okay, I need only this side AD. It's very easy to get this side in the triangle ABC. This is a right angle triangle. I need one side and I have two, so I'll use Pythagoras. So AD will be the square root of 10 power 2 minus 6 power 2. AD will be 8 centimeters. So now I have AD 8 centimeters. Okay, AD is 8. So I can get sine B opposite over hypotenuse. 8 over 10 is 0.8. I can also get cosine C. Cosine C adjacent 6 over hypotenuse. So 6 over 10, which is 0.6. So this is sine B and this is cosine C. Find the value of sine B plus cosine C. Add the two numbers together, I'll get 1.4. Okay, this is number 1. Find the value of sine B plus cosine C. Now find the value of tan the angle CAD. Where is CAD? This is CAD, so this angle. Tan this angle. The tan equals opposite over adjacent, so 6 over 8. Opposite over adjacent, and simplify it to get 3 over 4. Divide by 2 up and down. This is number 2. What about number 3? Show that sine C cosine C greater than 1. We calculated before and we see that sine C plus cosine C equals 1.4. So it's greater than 1. And find the value of sine power 2c plus cosine power 2c and deduce that sine power 2c plus cosine power 2c is less than sine c cosine. Okay, at first here sine c plus cosine c 8 over 10. This is sine c. This is c. Okay, sine c 8 over 10. Cosine c 6 over 10. Add the two together, it will be 1.4. So this is greater than 1. This is the first part of the question. Okay, find the value of sine power 2c plus cosine power 2c. Okay, sine power 2c, it means 8 over 10 all power 2. It means 64 over 100 plus 6 over 10 all power 2. It means 36 over 100. If you add the two fractions together, we will get 100 over 100. So sine power 2c plus cosine power 2c equals 1. Okay, so this is less than sine c plus cosine c because it was 1.4 and here we have only 1. Okay, so this is number 3. Okay, let's take another exercise. In the opposite figure, we have a square ABCD. Okay, this is a square A, B, C, D. The length is 24, so each side is 24. Here 24, 24, and 24. Okay. We have also E is a point inside this square. This is E. It's not a midpoint, it's only a point inside. Okay. BE equals CE. BE equals CE. So this is an isosceles triangle. OE equals 19. This is OE equals 19 centimeters. OE is perpendicular to AD. Okay. So if we extend it, it will be perpendicular to CB. Okay. If k cosine x minus sine x equals 1 over 13, find the value of k. So I want sine x and I want cosine x. This is x. This angle is x. What do we need to get sine and cosine? We need the opposite. Okay, this is a right angle. So I need this opposite and we need also the adjacent. Okay, the opposite side is 5. Why? Because this line is 24. 24 minus 19 equals 5. So this part, the green part here, is 5 centimeters. Now we still need CF and EC. Okay, this side is 24. And we have an isosceles triangle and perpendicular to the base. The perpendicular to the base bisect the base. If you have a perpendicular drawn from the vertex of the isosceles triangle perpendicular to the base, it will bisect it. So CF equals FB equals 24 over 2, which is 12. So here we have 12 and here 12. Okay. Okay. So I have here 12 centimeters. I have here 5 centimeters. I need the hypotenuse. I have two sides in right angle triangle and I need the third. So directly you will apply in Pythagoras theorem to get EC. Okay, AC is the hypotenuse. So hypotenuse equals the square root of 12 power 2 plus 5 power 2. Now we know that EC equals 30. So here we have 13. Now we can get sine and cosine x. Sine x equals opposite over hypotenuse 5 over 13. Cosine x adjacent over hypotenuse 12 over 13. Okay, I want cosine x minus sine x. So we said before sine x 5 over 13, cosine x 12 over 13. I'll get k times cosine x minus sine x. Just substitute 12 over 13. This is cosine x minus 5 over 13. Sine x equals 1 over 3. And here we have k. Okay, I'll calculate it. 12 minus 5 is 7. So 7 over 13 times k equals 1 over 13. Then k equals 1 over 7. Okay, by cross product, k equals 13 times 1 over 7. 13 times 1 over 7 over 13. It will be 1 over 7. Okay, it means this part means in another way 7k over 13 equals 1 over 13. So k equals cross product 13 times 1 over 7 times 13. So it will be 1 over 7. Okay, so now we get the value of k, which is 1 over 7. I hope you understand our session today. I hope it's useful to you. Thank you very much for watching. Next session we will continue, but we will study the main trigonometrical ratios of some angles. Some certain angles we will study the trigonometrical ratios of them. Thank you very much for watching. and goodbye.